Well, today we're kind of moving sort of from those more in-depth scientific discussions, and it's been a great couple of days of discussion, and we've captured all of the information. All of the slides and the recordings for the last couple of days are available on the workshop website. So Brian will just put that link in the chat for everyone so you can have a look there. So today we're now going to move on and start looking somewhat to kind of the future and what we're hoping we might want to move to. So we're going to have a first session where we're discussing the sustained mode challenges. So Zeb will be talking through kind of setting the stage of that. And we'll be looking at what the challenges potentially are for the historical and the scenario forcings. But then really looking at kind of refining what the current process looks like, what the issues are there, and then what we want to look, potential some options for how a sustained mode might look going forward. Because then in the plenary session, we want to look at that need for the sustained mode forcings, because there's no point doing anything unless somebody wants it. So we've got a user panel and we'll have some insights from a couple of key users who will be telling us about their perspectives. We then got lunch, and then we have afternoon plenaries where we're looking at kind of what has been happening during this current CMIP7 deck forcing suite development. So Paul and Vishali will be telling us about that. Zeb will also be sort of summarising all of these potential challenges that we've been discussing in a bit more detail in this first session this morning. And we've got a funders panel. So we have 5 of the funders who are going to tell us a bit about what they currently fund and their sort of impressions of how a sustained mode could work within the funding landscape. Then after the afternoon break, we've got a bit of more activity. So Claire McIntosh from ESA is going to be running a breakout session where everyone will get a chance to sort of delve into some of these issues on the users and sustained mode a bit more in a couple of smaller groups. There'll be 2 online breakouts and then 2 in-person breakouts and a couple of sessions, and we'll come back for feedback. Then for those who are in person, there's a workshop dinner tonight. So we're going to start with Zeb for session 6 this morning, and I'll just share your slides.
Perfect. Thanks, Eleanor. So yeah, as Eleanor said, we're moving into this sustained mode question. So I guess the first 2 days have been much more, how do we get the fast track out the door and then CMIP7 thereafter? And now we're thinking about, we wanted to do this more regularly in a more sustained way. How might that look? And yeah, I would say it's probably fair to say right now we don't do this in a sustained way. So it's really a change in mode and a change in workflows. So let's go to the next slide, I think, Eleanor. So yeah, so for this session, basically, I'm in this role of setting the stage. I think I'll give one viewpoint, but the main idea of this is to provoke a discussion. So if we can do that, that'll be good. I get to have the first word, which is a privilege, but it should definitely be the only word because there's lots of things I don't know and don't recognize. So yeah, we'll talk a bit about refining some of these challenges, and then I will take that away and try and refine that for the presentation I'll give in plenary too, which will be surprisingly similar to this one. So for all of you in the room, I don't know, apologies or congratulations for your being able to hear it twice, depending on your point of view. I think that's basically the flow for today. So we'll start with kind of setting the stage and how I think about producing forcings roughly. So this diagram's pretty busy. Basically, you've got 3 sections I think of. So the grey one is producing historical forcings, the blue is producing scenario forcings, and then the green is stuff like putting things in the right formats, which aren't really science, but it's just keeping everything basically organized. And so let's maybe, let's go forward one more slide, Eleanor. So I think the first thing which we sometimes forget is that we're entirely reliant on raw observations to make all of this work. And so we've done a bit of work with the forcing teams to try and work out which observations we rely on and who provides them. So if we go to the next slide, I've got a bit of a summary where There's some pretty well-known names in here, but it's otherwise much more diverse than I expected, at least if you look at the kind of top layer or organization names. Maybe if you dig deeper, it turns out everyone's being funded by the same people. But at the top, it looks like basically NASA is key for 5 of our forcing data sets. NOAA is funding into 3 of them. The UK Met Office funds a couple, and then there's lots of others who are funding basically things which are only used by a single data set. So that's good in some ways that we have, redundancy and we're not entirely reliant on one organization. In others, it's trickier because there's more people to manage, more things to keep track of. There's also a few data sets where basically we rely on networks of things. So you kind of have this various funders thing, and that's a bit unclear exactly how those work often at the top layer, so that we could definitely get more information there, which might actually bump all of those numbers up by 1, 2, or potentially even 3, which would change things a bit again. So I think that's one thing that we can't forget, and that in all these discussions about a sustained mode, it really starts with the raw observations, and Paul can tell you lots of stories about what it's like to have one of your key data sets stop appearing and the headaches that introduces. So I think that's really one key thing when we're thinking about setting the stage, is that raw observations sit underneath this, and we can't forget that, and we need to make sure that funders understand why putting up more satellites, why having observation networks of people going out and getting flasks of data really matters, and it's so important for this whole machine to work. So that's the first one for observations. Let's go to the next slide, please. And then I think the second thing which I figured out doing this diagram is that there's lots of pieces of this process which are still very much research science. And so Paul has spoken about that a bit, but there's lots where there's still ongoing research to be done. But then there's also bits where you can think about them as much more sustained science. So I don't know, maybe 2 very easy examples. I would say our greenhouse gas concentration stuff is probably more at the sustained end, where we have a relatively stable system. The uncertainties aren't that high in the scheme of things, especially in their radiative effects, and you could basically do that on a more sustained footing. Whereas I think, Thomas presented very nicely yesterday on the volcanic, where this pre-satellite question is really fundamental research science, and it's not clear what the right answer is. So I think most of our forcing sits somewhere in that spectrum, and I think that's another thing which we can't forget. So whilst we're talking about sustained mode today, there is still a lot of research science to be done and working out how we do that distinction, if there is a distinction, how we kind of move through the spectrum from blue sky research through to more sustained mode research, I think is a really interesting question, and an unanswered one, or at least I couldn't think of any models that really made sense to me straight away when I was putting this together initially. So let's go to the next one. And then I think, at the end, there's a couple of pieces that I would just say they're just not research. They're not climate research, right? So it's stuff like basically database management, naming conventions, validation of data. So they might be computer science, but they're definitely not climate science. But they're really important for just making the whole thing work. And so I think that's the other piece of this puzzle, is that if you want to have a sustained mode, you also need some of the professionalism that comes from doing the same thing over and over again. And that's not generally what research does. Research is about new, latest, interesting, not make sure that you can keep turning the handle. So I think that's an interesting question and an interesting challenge for looking at how a sustained mode could work. So having spoken about all of that, I just want to go back a little bit on the next slide, which is when we're talking about a sustained mode, what do we actually mean? So in plenary 1, we'll discuss this further, and Helene will give us a nice overview and a much better and more in-depth introduction to this. But to just at least give you something in your head to think about while we're having this discussion, a starting point is basically approximately annual extensions of your input forcing data. So for someone like Gavin, that would be helpful. Every year you get some sort of kind of the last year of data we've got gets added on top. You don't go and update anything previous to the last year, you just extend. So you don't have this thing of, if you've got a large ensemble, you don't have to go and rerun the ensemble, you just get to add 1 more year on, for example, which would help a lot of those sort of users. You would definitely want to do this for historical data. You may even do this for scenarios, depending on IAM's appetite to put out annual updates, our appetite to run it through all the machinery. That would be an open question. And I think ESGF publication would be a key part of this work, or similar. I mean, I think ESGF is basically the only option and the best option right now. But that's a really, really key part of it. So I think we're trying to move out of things being flicked around people's inboxes and through Google Drive links and FTP links and whatever into more common, findable, searchable data sets. And then I think the other question for a sustain mode is, yeah, what frequency would you bring in updates, right? So how often could we turn up and say, all right, we've completely changed our assimilation algorithm, and now the entire data set looks different, and here's your update, right? So if we do that every year, it's going to be a complete pain in the neck for anyone who's trying to do large ensembles, anyone who's trying to do, I don't know, medium or seasonal forecasts, because it means they have to rerun their whole spin up essentially. And then, but at some point the methodologies get out of date and you need to make changes, or you lose one of your observation networks, like what's happened to Paul, and you kind of don't have a choice. And so trying to figure out how often would we do these updates versus extensions, I think is a good one. And I just saw Carlo's message in the chat. Carlo, I just want to double check the distinction you want to make is between extension and update.
No, I thought it was an important. You were mentioning already this distinction, and I think when you talk about the engineering part on the right of your diagram, that has a lot to do with the extension mode, and is, as you said, is not purely science; is more operation to some extent. There is maybe a small addition I was about to add in the chat, and is the need for reprocessing, and reprocessing somehow sits in between the two to some extent.
Yeah, and that's definitely one I'm not super aware of, is this reprocessing idea. Yeah, so I'll make this last stop point, and then Paul, you can jump in. So I think the last one there is that for some users, they kind of want some guarantee of stability, essentially. So you might say, okay, we will provide you a data set which is consistent with the one we released in 2021 up until 2026. And at that point, we reserve the right to change the methodology and stop supporting that data set. So people can plan around it, they can do stuff. It'd be a bit like your iPhone, but rather than an iPhone where it's guaranteed to be out of date in a year, we'd probably go something slightly longer, more like a Fairphone where you get 7 years. Paul.
Yeah, thanks for this, Seb. I think it's really kind of good to try and put things in context. I mean, one of the things that I'd say about ESGF, for example, a real advantage of that system is the fact that there are a number of contributing agencies, funding agencies, etc., that actually underpin that. And so just as a nuts and bolts example with input from MIPS, where we're collecting all these data sets, that's being copied across quite a number of different places at the moment. And so DKZ, for example, has got a live copy of what we've actually got here. So in a situation where the lights got turned out for hardware failures, funding problems, something happens politically, for argument's sake, we would actually then be in a situation where people would just go from one place to another. And so we really need to try and think about how we can be as resilient as possible. Hopefully Copernicus can help out with this too, to make sure that we put stuff in one place, but then that can then be trivially copied around the place, which is what the ESGF system tries to achieve. And so coming up with standard formats, standard ways of sharing information, etc., is a really good way of trying to grease the wheels of talking the same language and then making it far, far easier for folks to pick things up and run with it. And even better, if Copernicus can help out with this, is put compute next to where the data is, which means that then it facilitates even more investigation data sets and even more uptake of these data sets too. So just a couple of comments.
All right, I'm nervous about us completely losing our flow. So if it's okay for Charlie and Anka, can I put a pin in this? We'll come back to it in the discussion, because I think we're starting to get the discussion going, but I don't want to completely derail this. So I think that's kind of the overview of where I see basically how this process sort of works. So you have obviously the raw observations, the research science, potentially sustained science, and then there's a kind of engineering, reprocessing, this sort of stuff, which goes around the whole thing to make it work and usable for people. So I think the next thing is, where are we today? And so I would say today, forcings are mostly, almost exclusively produced by researchers in research organizations. Direct funding for producing CMIP forcings, I would say, is the exception rather than the norm, although that's changed in the last 6 to 12 months. I think partly through to a huge effort from Eleanor, the IPO, to go and work out how we can make this happen, especially for me, which I'm very grateful for. And I would say that, we're getting better at sharing tools and knowledge. So the kind of engineering side is improving as well, but it's definitely not perfect. And I would say that there's lots of problems which are solved by different groups. So we essentially end up solving them n times rather than, once or twice and then sharing the solutions. So I think that's kind of where we are roughly today, but we can dive into that a bit more. So let's go into the kind of the next section, which is my view on some of the challenges for both historical and scenario forcings. I'll go to the next slide. So one more reminder, because if I don't say this, Paul's going to be mad at me. There is still lots of research to be done. We're not in a position to move everything into a sustained mode tomorrow. And I think supporting both research and sustained science will be a challenge, but I think it's a really interesting one, and it might bring really big benefits to both sides of the picture. So that said, let's go to the next slide, which is kind of my view on this, perhaps slightly provocative. So I think the first thing is that we produce data, so we're able to do this, and so I think we have solutions to a lot of the challenges we face in terms of just research questions, like how do you pull together a volcanic forcing set? How do you pull together aerosol plumes? How do you pull together land use change data sets? So we have something to work with and something to start from. And in my view, for sustained mode, the issue is really capacity. And I'll get more into that into a second. And so I think the question that I ask basically is, like, why don't we have the capacity to support a sustained mode already? And so to unpack this a bit, I'm going to dive down a bit deeper. This, as I said, will just be my view. So I'm super interested in thoughts from the floor, which I'm sure will get thick and fast once I stop talking. Can we go to the next slide, Eleanor? So we're going to go back to this diagram. If we go to the next one, then one of my first observations is for a sustained mode, you basically need to run the same thing more or less over and over again. And I would say that scientists are trained and funded to do new things. We're not funded to do the same thing over and over again. And so maintenance is either unfunded, or when it is funded, scientists are the ones doing it. And that's not really our expertise. And it's not really aligned with most of our key career KPIs, right? We don't get paid to do maintenance. We get paid to do papers, basically, if you ask most people. And so it's kind of like asking your plumber to do the wiring in your house, I would say. There is this mismatch in expertise, interest, and desire, which is, I think, problematic and a real challenge for setting up a sustained mode, is how do you get the incentives pointing in the same direction that a sustained mode points. So that's the first challenge, and I think the second one is basically, my slides are slightly out of order, that's all right. So I think when you look at this, if you look at this diagram, and you can do the same thing around system scenario forcings, kind of we've got all these forcing providers who are running usually local scripts, generally without all the key ingredients you need to make your workflows reproducible. And we're asking people to do this year on year, despite the fact that it's not what we do. It's just like not really aligned with all the things which our employers basically tell us are important. And so I think that's a challenge. And the question is, how do you get that right so that sustained science can fit with research science, and who are the right people to do it? And then we move to the right of the diagram. If we go to the next slide, where at the moment, basically for input for MIPS, it's a combination of Paul, Sasha Ames, and me, basically doing our best to make sure that this all sort of fits together, that standards are followed, and that data gets published. It's the three of us trying to keep the house not on fire most of the time. And we're doing, I would say, actually doing a pretty okay job right now, but like none of us are trained in database management, for example. Like I didn't grow up doing computer science, data structures, what are efficient data structures, how do you validate things really quickly, that sort of stuff, which is kind of what you need. So I think this leads to my second observation, which is on the next slide, which is that for sustained mode, you need this capacity to handle all the data, to check it, to make sure it's clean, make sure it's findable, make sure you don't have broken links, all that sort of stuff. And at the moment, we've got super limited capacity for this. And we're relying on, I think, a lot of goodwill. And I think our forcing providers have done an incredible job of basically being patient as Paul and I do our best to give feedback, and they do their best to comply with standards, and then we see what feedback we get from modelling centres in the meantime. But we do have, I would say, quite high reliance on relatively few people. And I think that's a challenge for data providers, because they just don't get as much support and shared tooling as they could, which would make their life much easier. And I think also for data users, it's a challenge because not everything gets caught. So users still end up with this thing that they don't have as smooth an experience as they could. And I'm in some ways, fortunate position of kind of sitting on both sides of this fence. So I both use and help produce some of the data. So even yesterday, I was trying to download some of the biomass burning data. And because we mucked some of the variable namings, you just can't find them on the ESGF. stuff like this happens, and I think it's literally just because we just don't have enough eyes checking things before they go through, and we don't have enough capacity to support data providers to help them get things into the formats we need. And my slightly provocative way of saying this, which is on the next slide, which is basically that we don't have capacity to support a sustained mode already because it's no one's job. And I think my view is that there aren't enough people in climate science whose entire job is to provide a solid base for the climate science. And if you put it another way, like a chemistry lab with no lab techs would be a disaster. And I think in climate science, we have basically labs without lab techs, and we all pay the price for that. So I think the next slide is my question of, well, how do we get the capacity we need? One option you could think is you get research science to do this. Now, as you can tell, I don't think that's an ideal solution because A, they've got the wrong skills, and B, the wrong working modes, and C, it's misaligned with their career incentives. Another option would be some sort of sustained science team. Now, this could work, and I think there are models we could learn from. It could also be very expensive, so it's going to require some sort of appetite to do this and figuring it all out. And I think it also requires very good organization and coordination to work really well. So I think it's definitely possible. I think it's great we're having this conversation, but it's probably not going to happen overnight. And so there's quite a lot of thinking to be done, I would say. Let me just check my notes very quickly. Yeah, nothing to say there. Okay, and then there's, on this kind of line of thought, I'm not the only one who's thought about this, so we go to the next slide. Bill and Stevens put out this paper which gave some people conniptions, so I would say. One of the quotes from it is, in retrospect, it now seems clear that attempting to establish and maintain operational rigor within the research environment is counterproductive. Now, I'm not sure I completely agree with the quote, but I think it does lead to an interesting question, which is basically like, what's the right model for sustained working science? And so in a lot of software organizations, they say that the code reflects the org chart. And so if you just split the sustain team from the research team, you might just get basically two code bases, which doesn't really work either. So I don't think just splitting them is necessarily the right choice. But there is, it's not obvious what the right answer here is. And I don't think this idea that you just split the two completely solves it either. But I think having just the research scientists trying to do the sustain mode, as we kind of do currently, is the right answer. And so there's some, middle question, trying out models, seeing what works, seeing what doesn't, to be done over the coming years if we want to go this direction. Okay, and I think the next slide is kind of some prompting discussion points from me. I'm sure people have got some notes already. So I think the big one for me is, how do we build capacity for sustained science for forcings? So A, how do we support the research, both raw observations and research science that is needed alongside the sustained mode? How do you build expertise in a sustained mode? Because I don't know if we have much of it right now. Where should that expertise sit? How do you organize yourself so there's a smooth link between raw observations, research science, and sustained science over multiple years, particularly if your sustained teams don't sit in the same orgs as your research teams, which might be the right model. And a very CMIP-centric question, and I know not all this is CMIP, but some of it is, which is, could CMIP experiments become basically routine rather than a huge lift? So, could we spend 10% effort every year rather than 100% effort every 5 to 10 years as we currently do? And so Jane was talking yesterday about how in UK ESM, they kind of sit down, they deal with all the forcings once, and then they don't do it again. And I think in the current mode, that makes total sense. I guess my question is, could you make it so that that team doesn't have to get together, do a sprint, deal with it all, and then forget about it? Could it just be that people know how this works, and once every 4 months, they go and see if there's any data on the ESGF? If there is, they process it, and if there's not, then they go on to the next job on their list. So I think that's the discussion points where I'll leave them. I'm just going to run through 3 more slides, and then we'll come back to those discussion point slides. So just talking about what I'm going to try and do after this session. So if we go one more slide. So in plenary 2, I'll present basically a summary of this. I think the summary is intended to be a helpful guide for the funders panel. So that's where I'm going to try and target it, and I'll update it based on this discussion. I'll also listen to what happens in plenary 1, which will help better define what a sustained mode means and which users we're targeting. And then, if you want to jump into the presentation, you're welcome to, and drop comments, and I'll try and pick them up in the meantime. And then if we just go forward, one more slide. So at the end of this deck goes another 50 slides. We're not going to go through those, but it's kind of got like the status for each data set. So like what raw observations they depend on, what can they do extensions, can they do updates, how does their scenario stuff work? And I think, we can't do all of that at once, but I do think we'd need to be better at trying to track everything everywhere all at once. So, which observational networks do we think could go down in the next 3 years, and how would we deal with that? Which teams need a big lift so they can do extensions? Which teams can't do scenarios right now? This sort of thing. I think we're getting much better at that. But I think it's probably a helpful piece if we're going to try and push all in the same direction, is at least knowing where we're starting. So let's go back to the discussion point slides, Eleanor. I think that one's good. And I will leave it there and open up the floor. I'll hand back to you, Eleanor, to chair.
Thanks very much, Deb. So I think will we do a bit of a round on terms of sort of key reflections on what Zeb said to begin with, and then maybe start to look at trying to pull out what other challenges potentially people think, as well as the ones that Zeb's come up with. And then by 10 o'clock, we might want to look at if there's ideas about potential solution or structures that could help with solving some of these challenges. So in the room and online, have we got any comments? Anka?
If Paul asked the question in a non-rhetorical way earlier about Copernicus could or does do things, I could tell you now exactly how we work with the SGF and what we've done so far and what could probably work to be as a sort of basis for an extension. Or I can leave it till later if you want to focus on the questions, Alan, if somebody's more readily. It'll take me 2 or 3 minutes.
I think it'd be good to maybe let's look at the sort of questions we've got here. So about how do we build that capacity for the forcings?
Come back to me when you're ready.
Yeah. So how do we think we can support the research that is needed alongside the sustained mode? Jane, have you got a comment on that?
Sorry, I'm wondering if I'm preempting things. So mine was more on the SGF, but I mean, it could be how do we build capacity, because obviously it's key to building that capacity. And so I'm just thinking in terms of, can we learn in terms of how the SGF maintains things like the model outputs in terms of curation and documentation of everything that comes out of CMIP. But it seems that that same rigor isn't applied currently into the curation of the forcing data sets on there. So, and I'm thinking we probably don't have representatives maybe here, but maybe we should, I don't know if we do, but we can come back to that later again if it's more of a separate conversation.
Okay, so we'll maybe try and look at this sort of particular question about how there's almost research scientists doing jobs that they shouldn't be, almost like. So Gavin online, have you got a comment around that question?
I put this in the chat as well. Many of us work for organizations that do manage to do both operations and research in the same building. The operational stuff has been informed by the research and has been built by researchers, but after a while, these things can in fact move to operations. And one of the data sets that we work on is the GIS-Temp data set, and we're now also working with the IRI ENSO forecasts. These are initially things that were developed by scientists, where there was a lot of decisions to be made about how to do things, what to do, why to do things. But after a while, you build up a pipeline that every month you can just go click and you bring in the data that you have, and then you process it, and then it goes out. And that's a different role. The scientists, the research scientists, are not so involved, and you can maintain that with actually minimal input from the researchers. But every so often, as there was saying, people change their data sets, people update their formats, There are some groups that update their formats on a monthly basis, which is very annoying. But generally speaking, you only need to do the research to work out what's happening on a much lower cadence, right? So for GIS temp, we've had like 4 or 5 big updates over the now 40 years that's been operational. And so, but month by month, like almost nothing changes, and it's actually a low maintenance thing. In fact, it's not even a funded project. We just fund it out of our operational account because it's so easy. Some of the other things like the ENSO forecasts that were being done at the IRI at Columbia are now being done at GIS. Those are things that involve a little bit more, but again, they've been doing it now for over 10 years. And at every kind of month when they do this, it's basically you just push a button and it gets done. And many of the organizations that are represented here, Copernicus, the Met Office, NOAA, NASA, we have capacity to do this. We just need to make sure that it is directed towards this end in a way that both the management and the program managers understand both the need for it and the process by which this can happen. But this is, to my mind, this is obviously the direction that we need to go. And I think Zeb's talk really covered a lot of the issues there. So thank you very much.
So just coming back to you, Gavin, on that point, is the way that's worked has been within a single organisation. Do you think part of the issue maybe here is that a lot of the funding providers are spread across the world and across different institutions? So having that research and operational together becomes more problematic?
Well, I mean, I think that's obviously the case. I mean, the fact that most of this is being done by people who are not specifically funded to do this is hugely problematic, and it makes it very difficult to keep focused on this when what you're being judged on, or your annual reviews are being based on your papers or your proposals or something. It's very hard to sustain this in the face of that. Yeah, I think we can have international coordination on this, like ESGF is internationally coordinated, for instance. And so we just need to make sure that the funding agencies and the operational agencies are aware of the need for this and how broadly used these data sets are. One of the things that surprised me in looking into this over the last 6 months is just how far these data sets go into the reanalyses, into the decadal predictions, into the subseasonal predictions, and a lot of these people, they have operational arms and they aren't, but they're just expecting this stuff to exist. And we can perhaps prompt those organizations to understand that those data sets don't just exist, they need to be created and maintained. And maybe they, in fact, may be able to help.
Thanks, Gavin. Do we maybe, sort of building on that, discuss perhaps the ESGF? So is there a role for ESG? Oh, sorry, Helene. No, on you go. On you go. Carry on. Sorry.
I was just going to, well, perhaps it's related actually to the ESGF point as well, is how so Gavin talks about trying to get the organisations internationally to work together. And is it really viable that we could get that to happen? I mean, even in ESGF, we've seen that it works, and then the US is funded, but the EU isn't. And how do we bring the rest of the world on board with this as well? So, yeah, more questions than answers, I'm afraid.
Anka or Carlo?
Yeah, actually, there is quite a vibrant discussion at the moment in the document online. So it's maintaining the two. But one of the points that is reflected in the discussion is potentially answering your initial question about the funding or the support for research, is the fact that a lot of the things that have been said in this room of the last 2 days actually are not visible outside. So it's not visible, in my opinion, the issue, the research issue that exists, the jumps that we've seen in the data set, or the lack of understanding of certain element, and is not visible their importance for the climate projection, for climate services, if you want, for the interface with society. So in a sense, in the movement to a different setup where this is no longer just research, but is research plus operation, then I think this is probably the starting point, raising the visibility and the importance of what is being done, because ultimately we, at some point, will need to go basketing for money and to support operation and research. And without that visibility, it will be much more difficult to get that social support for make this happen. So I would think that increasing the visibility of what has been discussed in this room and their importance for the community is probably one of the first thing to do.
And how would you do that?
Well, in a sense, so I've been, and I see that Gavin has put the hand up, so probably he has something to say on this point, but even if people like me who have been working on and off on climate for the last 20 years somehow, well, I was surprised. I learned things over the last 2 days. Well, this means that maybe as a community, we haven't done a sufficiently good exercise in even talking to one another or explaining the status of the state of the art at present. So how do we do that? Well, I think we have to go out to be a bit more loud and visible about this. And actually, this, in my mind, will also strengthen our credibility in terms of when we discuss about climate. The fact that there are uncertainty on the forcing, the fact that we need to understand this uncertainty better, the fact that this uncertainty have an impact on our ability to project the future, that's ultimately a matter of our own credibility and the trust that the community can pose in the output of climate programs.
So what do you think are the best pathways for doing that?
Well, I haven't prepared a 5 years plan on how to do it, but in a sense.
No, just an example.
Yeah,
It's just useful
example,
to actually have like tangible examples.
Right. I mean, an example, just to be practical rather than just theoretical, is we have been spending a week here in 4 days tomorrow here in Reading, and we have been discussing all these elements. Having a short publication out of it, not meant as a technical publication, but as a sort of state-of-the-art review analysis. Something can be published on BUMPS or a sort of a generic journal, saying, well, these are the main challenges. These are the things we don't understand. These are the impact this limited understanding is having on our ability to project the future climate. Well, that would be very useful, in my opinion.
Okay, so we'll go to the online. So Steve.
Actually, let Gavin go first because I'm bringing a new topic. Side topic.
Okay, Gavin.
Okay, so this is slightly coincidental, but it's not actually really coincidental. We have an opinion piece that will be coming out in the New York Times either this week or next, talking about how frustrating it has been to not be able to explain what's been happening in the climate system over the last few years because we have not been able to have updated forcing data sets as part of a sustained mode. And generally speaking, these things, they're not very in depth. They just make one point, that's the point that gets across. But that will be relatively high profile, and my anticipation is that will be read by funders and program managers much more than the proceedings of a workshop will be. So I think we can use the public's general interest in what is actually happening and why why is it happening to prompt people to understand that that if you want to understand that better and faster and more rapidly, then you need to support this kind of sustained work that we're talking about here.
Thanks, Gavin. Paul?
Yeah, I was just going to chime in. I think this is somewhat repeating what you said before, Gavin, but being scientists, we're all interested in a question and answering a question. We're not really thinking so much about how we make that, the ability to answer that question sustainable at all. And so I think one of the things that we kind of need to do, you've pointed this out before as well, the use of a lot of the stuff that CMIP has been producing is something that we've never quantified the impact of that. And we've never actually pointed out to all the modelling groups, thank you very much. Your data sets have been, downloaded a million times and underpinned a whole bunch of scientific papers and enabled a whole bunch of impact stuff to go on that's in grey literature. And I mean, like, there's a reason why the CMIP acronym actually carries so much weight. And the reason is that the community's gotten really organised and done things on a research budget that's had kind of sustained impact and built knowledge that's underpinned the IPCC assessments, etc. And so I think what we all need to do is when we're writing that next paper, in your conclusions, you say, thank you very much to everyone that enabled me to do this. And by the way, this needs to be, maintained if I can answer the next round of questions, etc. And so, I mean, even within, say, GizTemp, Gavin, you've got a dependence on the HAD SST product. Do you point out the fact that thank you very much HAD SST every time a GizTemp publication comes out or whatever? Like, we really need to kind of join.
Actually, we use the NOAA ERSST, and yes, we do thank them on a regular basis.
Well, I mean, but we all need to get in that, putting up logos, when you're giving a presentation about something, saying, by the way, thank you very much for, all these agencies that have facilitated what we've actually come up with, and let us know how we can write you a letter of recommendation, or ensuring that is sustained. I mean, it's one of the key things that Zeb was pointing out. A lot of these forcing data sets are dependent upon data products that we all assume is going to be there. We might want to answer a question, but that question will not be answerable if, a satellite falls out of the sky and is not replaced. And so I think we really need to think about doing that systematically as a community. And, if there's a template we can all follow that makes it trivially easy to do that, and it's, it takes 30 seconds to do it, then let's do that instead.
Okay, Ben, is this on this topic? Just
vaguely. I mean,
Claire, do you want to come back in? Just because then I'll allow Steve to come in after, once we've kind of finished on this.
Just to respond directly to Paul's point, I think that is a really important point. Most of these forcing data sets are part of a data pipeline. They take upstream data sets and they produce something new downstream. And as a data provider, it is very difficult often to know who your users are. And the thing you need above anything for sustained funding is people saying, we use this, it has reach. You're talking about, Argo is always 5 years from failure. There are huge international sustained funding efforts to build satellites, to build the kind of the base observation networks. We're part of a pipeline here. And those links from users feeding back up the chain can be very, very hard to map. And that applies at every step of the chain. And I think it's fairly clear to me, one of the interesting things that's come out of the last few days has been the consequences of getting it wrong. So you talk about making this high profile, but there are the forcing data sets not being well characterized in terms of their properties and their uncertainties. That has major implications for what the models produce. But those links have been broken up until now. And I think that communication pipeline is going to be really key in anything we implement.
Who is responding to the current chain of discussion? Right, okay, Matt.
No, I think that this is a critical point, and I'm curious, I mean, we're talking about what are the dissemination products that can help get this kind of message out. And so Gavin brought up the New York Times op-ed, which I think I generally agree is a better mode to reach non-scientists. But at the same time, I mean, what we just heard here, I'm wondering, has anybody actually developed like a full dependency tree? So like what, for all of the forcing data sets, who builds on what and et cetera? I actually knew the answer to that question. So Zeb has, and I think if we talk about outputs of this meeting, and if we want to have a summary review paper, this is a critical part of that, I think, is to sort of say what the state of the art is. And part of that state of the art is to identify, well, if I'm going to use the scenario forcing for SSP 119, that actually has depended on 15, 20, 30 other data sets downstream, basically, and being able to actually map that, and I think is a critical output that we can have from this meeting.
Extremely brief, just a reaction to Claire. When I say raising the profile, I'm not just I don't mean just trumpeting how great the work is. Actually, highlighting the deficiencies and the problems is part of raising the profile. You know, we have a huge building that builds on this forcing, and the building is not just CMIP. It's actually all the users downstream of CMIP that are no longer just research. You know, it's more and more becoming more and more important for society, and I can make really concrete example of users of that information in finance, in insurance, in water management, and so on. Well, highlighting the fact that some of the foundation have problems, and we need to, well, I think is raising the profile as well.
I just think,
yeah, I mean, so I guess this is a good discussion, but I guess my thought is that it would be useful to think about this in a less binary way. So we're talking about this sort of complete imagined operational change in the way that we run this entire enterprise, and it's huge, as we've already demonstrated. Like there's a huge number of institutions, there's a huge number of dependencies, which make it, you know, even compared to a product like GISTEMP, means that this is a much bigger deal in terms of the coordination between different institutes and countries and funding agencies and things. But maybe we could rationalize this a bit by not thinking about the operationalization of the entire CMIP, but isolating parts of the activity which could benefit from being updated more frequently. So, for example, on this cycle, if we decided that we were going to have a revised historical simulation coordinated in 2027 or 2028, then that would be a useful thing to aim for. And then we could sort of, I think it's always going to be the case that there are going to be elements of CMIP which fit better as scientific exercises, and there are going to be elements which have a necessity to be treated in a more operational manner. And I think if we went through that process of sort of isolating what those high priority sort of flagship products would be, that it really would be good to have, you know, annual or biannual updates, then we could have a sort of a discussion on a more on a smaller problem, but a more well-defined problem as well.
Okay, Paul?
yeah, I was just going to throw like an anecdote of the past, why this is kind of important. So in AR6, as we're going through the process of putting together the assessment, there was a recognition from the forcing data set providers of the volcanic forcing data. Actually, there was a problem in the volcanic forcing, and it wasn't small, but one of the things was at that point in time, CMIP6 was full steam ahead. All the modelling groups were just running with this stuff. They didn't know there was a problem. And we had to figure out pretty quickly what the hell this was going to, like, was this going to undermine the historical experiment? How big was the bug in the forcing? We managed to get a number of groups to do some simulations which proved after, you know, at least in 2 models, that the error was basically within the noise, the ensemble spread of at least 2 models. So it didn't matter actually. But if we didn't catch those if we didn't like pin that problem and basically be honest with ourselves, it would be a huge gaping hole that could undermine CMIP credibility in CMIP7 timeframes, for example. And so we need to do a better job to make sure we don't open ourselves up for criticism, because in a situation where we're spending a huge amount of computer time producing CO2 emissions, etc., whatever, and they're majorly flawed, and it gives you an opportunity for, I mean, particularly now with like the uncertainty and no one trusts anyone, whatever, you give us a little chink in the armor that people can kind of, you know, stick a crowbar into. It's really going to undermine a whole bunch of stuff. And so I think as we're trying to kind of build the case, etc., we need to make sure that we are doing the best job we can, and we need to be honest about the fact that if we do have problems, we try and quantify what the impact actually is, and we get on the front foot about it and communicate the fact that we know there's an error, the error is this big, and we're working on trying to solve it. So just an anecdote from the past, I think.
Maybe it's good to just kind of tie this part of the discussion off to go on to the sort of capacity building element, particularly at that software end. So maybe just Zeb, do you want to, and then Claire, if you've got a short point after that.
I'm trying to pick up on Ben's point about picking your battles. So I think, yeah, for relevant timescales, decade, 2 decades, things will sit on a spectrum. And I think that was one of the points I was trying to make. So we're going to have this raw observations to research science, sustained science to operational spectrum. People will sit at different points on it for a long time, I think. We know there's lots of uncertainties we haven't fixed yet. But having said that, I actually think that from what we've done with what we've spoken to with the forcing providers, we could do an annual extension every year if we had the funding for it now. The only forcing providers I don't know about is one, Paul, because his ROBS data set went down on him, but he was doing every 6 months, you're releasing a new one up until 6 months ago. So clearly able to do it, just needs a new raw data set. I don't know if Michaela's online. I don't know quite where ozone and nitrogen deposition's up to, but I'm guessing that would be possible, but maybe difficult computationally. And then the other one I don't know is Bernd, who's also online with solar. Given how organized Bernd is, I imagine he could do it, but in the slides I've got, it's written down as in development. So I think if you wanted to pick a starting point, that's actually not that far away and would be doable.
Claire, just to finish off this, and we'll move on to Steve next.
I'm just picking up on Paul's point about sort of the hidden horror in data sets and being a little bit careful about the ramifications of that. I think the very first step there has to be transparency and characterization of the data sets, which hasn't been done in any systematic fashion. I mean, we saw yesterday the impact of changes in variability in the biomass burning data set on exactly what the models produce. That's enormous. And not knowing where those things are until years after CMIP model runs are done, that opens us up much more, I think, than anything else, is just not knowing where these things are until somebody else finds them serendipitously.
Okay, sorry for the long wait, Steve, but I think we're moving back now to this or particular question that Zeb had raised about this sort of community capacity building around that software end.
Sure, and no worries. This is great discussion. I wanted to bring up, this is a very dispersed community, as we've been talking about, with a wide range of actors. And, one of the things that we've experienced, just I can give our experience at my institute, over the last really 2 decades, is really a transition from working in sort of science mode where people, do sort of site analysis and so on, just with whatever platform, whatever coding they want, to having things, adhere to coding standards, have code reviews. We've gotten to where things are on repositories and so on, and that's just now standard procedure internally. But when we bring new people in, starting from postmasters, bachelors, postdocs, we have to train everyone in good coding techniques, unless they happen to have a computer science background. Because the computer science folks are the only people that get trained in this in university. People may get exposure to it, but they don't really know good programming techniques and, encapsulation and all these different things that are now standard. So I think there's an element of sort of broader community building of just these skills and tools. And there are some webinars in different communities that aim to do this. There's one in the high performance community that works pretty well. I think it's called Ideas. So I think we could think about that, and I think that builds up the skill set of the community. And if we have people at the sort of research level, we saw a number of these new forcing data sets and so on, where it's research, it's somebody working on some piece of this and developing data set, and that's exactly what we want. We want those new ideas and those new things coming along. But then if everybody from that stage can get exposed to, well, here's some things you can be thinking about. Here's some resources. You know, we can have some ongoing seminars or something about how you do this in a more robust way from a software standpoint, and learn from each other, and be doing, even have cross-institutional code reviews, you know, that sort of thing, to really start to get some insights and comments. And and then this gets back to resources, because of course, you know, as I wrote in one of my comments online, we sort of do something rough and dirty for our research, and we don't put in the effort to design the code and do it well. And sometimes that's justified, but often it's sort of a false choice, right? That if you actually put in that time ahead, because you think you're doing it once, but even in research, you're going to do it 8 times, 10 times, 20. So I think just thinking of ways to, as a community, to raise the skill sets and do that sort of capacity building in terms of those skill sets would be valuable.
Thanks, Steve. Paul, do you want to come in on this point? No. So do we have any reflections on what Steve suggested there? Zeb, have you got any thoughts on that?
I mean, yeah, I've got plenty of thoughts. I think for me, it boils down to 2 things. I think one, a general lift in like scientists' understanding of the software stuff is good, but I do think there's a limit, right? Like being really good at it means you have to basically love it, because it's psychopathic at the bottom. You know, anyone who's written C or C++ or Fortran knows that like it doesn't make sense a lot of the time. And so if you want to be really good at it, you need to love it. And like expecting every scientist to love low-level programming is hiding to nothing. So I think we need to be aware of the like, you can't just make every scientist a shit-hot Fortran programmer. You need to also think about like giving them support, and that it's not necessarily going to be the same person every time.
Yeah, and I agree, if I can jump in, I agree completely. And I think then it's a matter of thinking about the cross section of that with institutional context, and you know, at times, once a data set becomes more important and more important for the sustained effort, then you start thinking of, well, you know, it's not like somebody takes it over, but maybe there's some institutional support somewhere that can help transition that to something more sustained, but still keep that research bit going. I mean, it's complex and it's difficult, but I think just, yeah, it's work on multiple fronts. But even on the institutional level, we're amongst the people that really are into this, you know, having some cross-institutional collaboration and consultation could be valuable as well.
Thanks, Steve. Matt or Jane?
Thanks, Matt. Yeah, so because I'm kind of following up on those points there, actually, which are quite interesting. So I think probably kind of the more operational centers probably have a reasonable amount of experience in this kind of area of bridging the gap between the science research and the kind of software engineering requirements. So in the Met Office, this is, you know, it's you know, the recognition of the role of the software engineer in an operational system is highly recognized. And, you know, in the good old days, you know, we employed probably more scientists, where now we are, you know, needing those software engineers more than ever. Where we do have that little bit of a clash, actually, interestingly, between our expert software engineers and us as scientists, is actually in that model input output space. So that requirement of what you need to put into your model to run your experiments, to generate your forecast, to generate your projections. The software engineers would very much say, I can help you build your infrastructure, but I do not understand that data set. I am not a scientist. I cannot review that data set. So I think this is where, so even internally in our own kind of structure of producing our forcing data to put into our CMIP models and other models that we use, we ourselves are having that battle of how do we best ensure that we are quality assuring and reviewing, code reviewing. We have all these processes that we want to put in place to ensure that everything we put in and take out of the model is top quality. And there's that role really for the scientists and the software engineer to really work hand in hand, but it's challenging because often the scientists, as you say, they want, you know, they don't see it as part of their long-term role or job. So they might initially develop that product or build that data set, but then they don't really want anything to do with it anymore because they've got their nice science to do. So I think raising that, you know, awareness that it is a little bit, but it's a really important overlap or common area where the scientist and the software engineer need to work together, but also trying to raise the profile of what goes into a model is also key important science. It's not just, oh, I need a data set to plug into my model. And I think that's kind of goes back to kind of raising the profile again of that, so that scientists actually do want to get involved in that. But it is a challenge. But I think other modeling centres must have similar, operational centres must have similar problems, and that are experiences that maybe we can tap into as well.
Thanks, Jane. Matt?
Yeah, this is actually a conversation near and dear to my heart because I spent a lot of time in grad school developing sort of lesson plans. So if anybody's ever heard of software carpentry, for example, I developed some of those, actually some of the original ones. And with the goal being to teach young new grad students how to actually, like some of the basics of scientific software development skills. So I think that that's a you know, a good end of itself. But at the same time, there exists a spectrum between training up good scientists and how to do good software, like research software skills, versus the resources needed to support a sustained, you know, operational process across multiple institutions. And I don't think you can get away from interacting and integrating more software engineers into that process to be successful. So I think it's a we need to do both. It's not an either or. I think it's a both, actually. But the other thing that I wanted to point out is that, yeah, maybe just from my personal experience. So being part of the forcing data set providers, we try very, very hard to have fully tested code, fully documented code. But at the same time, I happened to do that 5 years ago, and now we have to do it again, right? And so even though I did as good of a job as I could have done, I still have to go look at my code from 5 years ago. And I don't know if you've ever heard the anecdote that your closest collaborator is you from 6 months ago, and they don't happen to answer emails anymore, right? And so there's also a benefit to doing this in a more sustained manner, just so that it doesn't sit on the shelf for 5 years. The last thing that I'll note is that, you know, we sit in a room where I think almost everybody would consider themselves a physical scientist, and so very close to actually writing code on if not a daily basis. That you at once did this, but we also talked about other data sets. So when we talk about fire, we're talking about HIDE, right? So we're talking about population data sets. We're talking about a very interdisciplinary community in terms of data providers, where different communities have very different starting points in terms of their ability to do best practices from a scientific software perspective. So I think it's also important to recognize that if we're talking about really making this whole chain robust, that not every community is going to start at the same level of expertise that maybe the people in this room, their communities would start at. Thanks.
Thanks, Matt. Zeb?
So I just had one thought about something which for me really helped change the way I thought about this, which is that if you think about when you write a paper, if someone came to you and said, my first draft is what I'm going to submit, you would look at them like their head was on backwards. But at the moment, most of us would probably say, I write my code once and I don't touch it again. And it's like that kind of just doesn't work. You sort of need to write it 2 or 3 times. And I think that sort of stuff is where, like, scientists would go nuts if you did this, but that's kind of, in order to get really good stuff, that's what you need to do. And that's where some of the like the changes in mindset, I think, need to come. And then also just acknowledging that for some people, it's just a bridge too far. It needs to be someone else who does that lift for them.
Cool.
Yeah, I think the word iteration is part of the scientific process, and it's part of like any development process. You know, like you learn as you go. Hopefully you've done a good job of, you know, building something that means you can reuse a lot of it, probably not all of it. But if you go and rewrite something, I mean, Zeb talked about this a number of times, you know, the only way of actually getting something done is by trying to do it. You know, you can kind of strategize and come up with, you know, plans and whatever, but actually doing it is the only way you get anything done. And once you've figured out, you know, how you kind of did in a clunky way, you can go back and try and reformulate that and then modularize it and make it much more robust. And that's what we're doing. Like, this is the whole process of science. And I think iteration is something that we're going to have to get very used to. There was a whole bunch of presentations over the last couple of days where, you know, version 1 of a forcing data set wasn't as good as version 2, wasn't good as version 3. And as we're trying to use these things more and more folks are using them and picking them up, we're finding, you know, the more eyes are actually finding more issues and more questions we need to answer. The other thing that's also, I think we need to kind of recognise how lucky we actually are in 2024. There's been a number of people that have talked about MIPS, like we have an acronym that we all use, that we all assume that, you know, we know we're all pointing in the same direction, basically. So Douglas was talking about coming up with a fire MIP yesterday. Stephanie this morning was saying we need to do this as a MIP. We're really lucky. We've got a lot of goodwill and a lot of, like, you know, 50 modelling groups basically that are all pointing in similar directions, that have a really collaborative mentality that, you know, we're all kind of pointing at trying to answer the same questions, etc., and want to do this as a collective. But that is something that a lot of other communities do not have. And so we really need to make sure that however things evolve politically, you know, funding, whatever, that we try and nurture that goodwill, maintain it, and continue to build it in any which way we possibly can. Because like a lot of the successes and climate change successes we're going to have in the future are because we've actually, you know, gone from a whole bunch of developed nations that have done climate modelling to being in a situation where the CMIP project has enabled a whole bunch of other developing nations, for example, to get in and be part of the team too. And so, like, this whole facilitation, this whole inherited goodwill is something that, you know, it may have been done 30, 40 years ago, started, but we really do have something that's pretty special and pretty unique, and we need to try and make sure we can nurture and bolster that as best as we can. The forcing data sets is one part of that, but it's a really important part we've not paid a lot of attention to.
Okay, Vishali, and then we'll go to Steve online, and then Matt.
I wanted to come to a point that Jane made, ensuring the fidelity of the input data that we put in our models, and also the output that comes out of it. Data providers obviously do their best to provide their best versions of the data, and I have looked at it, but it's the community that actually looks through the data and helps to improve the different versions. So I feel like this is a community effort in terms of ensuring what goes into the model is correct and what comes out makes sense. Even with the output model, output data, you have to have, obviously the modeling centers can do their quality assurance only to an extent, but once the data is out and it's being looked at by different people, that's when we find issues and we'll need to go back and make those corrections. So in that sense, echoing what Paul said, it's the community of science practitioners that we've had that has helped to make things better over time in terms of input data as well as coming out of it. Yeah.
Steve online?
Sure, 2 quick points building on Matt and Seb. So yeah, absolutely. There's always going to be this separation. You know, there's always going to be this spectrum between science and computer scientists and so on. And we certainly have that too. But what we have seen is as you raise the standard that the average scientist in your group is working on, that link between them and the sort of computer scientists becomes easier. So I think that's, you know, all consistent. And then I think the other piece relates to the visibility. So there's another aspect of the visibility is giving visibility to the importance of coding standards and clean code and open source code and all these things. Really, you know, that we've seen that overall in the community, how as that visibility is raised and people now, you know, more and more, although not all the time, accept that as the standards. Yeah, I have to put everything on GitHub. I have to have it, you know, I have to have it open and so on. So I think there's that element of visibility that comes into here as well. And then I think raising the visibility and need for that infrastructure and so on then goes to the funders as well. You know, our funders at this point sort of, you know, support the fact that we need infrastructure, you know, because it makes things more sustainable in the long term.
Claire?
Just coming back to Vishali's point on data providers, and yes, of course, data providers try to produce their best data, but best in this context depends critically on the use case and the user requirements. And CMIP has some really unique properties in terms of what it wants, but what's become clear is that different MIPs might have quite different requirements in terms of stability and latency and those things. We can't give you good data if we don't have well-articulated user requirements. And one of the things I'm really excited about coming out of this workshop is how we think about what is it that CMIP needs and how does that differ across the CMIP universe, across the modeling multiverse, across wider users. Most of these data sets have wider users outside of this community. Can we map that? Because then we can give you data that you need.
I was just going to kind of follow up what Vishali said. I mean, I started looking at CMIP output and CMIP2, and some folks in the room may have never been back there. Lucky you. Like we've had a huge amount of like technical investment, which has actually enabled, you know, the CMIP6 output to be better than the CMIP5 output, to be better than the CMIP3 output. And a lot of the technical work has actually gone to trying to make those data sets more and more readily available, easily accessible, et cetera, whatever. That increases scientific productivity. Like there is no, like the payback is monstrously huge, is the take home. And so if you had to wrangle, I mean, who was I speaking to before about you were, yeah. So in a situation where you have a less organized MIP that people are not rewriting the data sets, et cetera, it is a nightmare to try and deal with these different outputs versus something that's kind of been sanitized through the CMIP process. And I think there's a huge amount of like front loading the technical work to kind of streamline the downstream use of these things. You know, AR6 wouldn't have been possible if we didn't have a very clean CMIP6 archive, because the timelines were way too tight to have to do a whole bunch of technical work to wrangle those data sets to make, you know, kind of sense of the data sets within the timeline of the report. And so I think recognizing that and making sure that we continue to try and invest in that technical at the front is going to pay a lot of dividends at the end, and recognizing also that, you know, 20 years ago we were not in the situation we're in now.
Deb? And then it would maybe be good if we can think about that question about where the expertise should sit, and that feeds into potentially about the ESGF.
All right, I'll do my best to come to that last so we dovetail in. So I think Claire's point about your user requirements is a nice one. Just wanted to echo and add that one, because it's very hard to build super general software, but if you know what you're trying to do, it becomes a lot easier often. And then, yeah, I think Paul's point about what it's like trying to deal with data on the ESGF, depending on the MIP, is a very good one. Some of it's relatively straightforward, some of it's much harder. But also I think we need to be a little bit careful about recognizing that if you're not on one of the host ESGF nodes, the ESGF is still not that easy to work with, I would say. And for increasing access, I think that's a really big challenge we need to think about, probably not in this room necessarily, but I don't think the ESGF problem is solved. I don't think the CMIP archive problem is solved either. There's still lots of ways to shoot yourself in the foot that I would argue shouldn't be there. But coming on to, yeah, potential ways to deal with some of this stuff. So I think Steve's point about lifting the coding standards is a really good one. And there's a model I've heard of, which I think exists in Germany, where basically what they say is we have an institute, I can't remember which one. They have a research software engineering team. So as a researcher, you can turn up to them and say, hey, I would like you to help me get this code up to standard. And what they do in exchange is they say, all right, here is a questionnaire for stuff like, do you have it on a public repository? Do you have version control? Do you have any tests? And if you don't get a minimum number of points on that question, they won't touch your code. They say it's too hard. It's not worth getting started with. And that might be a model to consider learning something from, in terms of you need to lift the minimum standard to a certain level, and then you can have another team work with it in a way that's actually going to make sense. So if you try and lift from nothing, it's too hard, but also if you don't give people support, it doesn't work either. So that might be one to consider.
Great, thanks, Seb. So maybe going on to where that expertise should sit. So that's maybe one example where there's one institute that has that kind of research engineering, software engineering expertise. But within CMIP currently, we have the ESGF, which has that sort of federated structure. So perhaps that would help with, as Jane's sort of point about needing the scientists to be close to the software engineers. So I don't know, those of you who are familiar with the SGF or use the SGF, do you think that expertise of software engineering could be built within the SGF Federation? Or should it be elsewhere?
Is it worth hearing from Anke now a little bit about how Copernicus works the SGF to see?
Yes, so my immediate thought in response to Eleanor's latest question is ESGF does part of the job, but software engineering comes and should come in other parts of the job as well. As far as I understand, ESGF's role is to just take the data, archive it, and then serve it, document it, and all the rest of it, not produce it in the first place. So the production, the industrial process that gives this data and pushes it to ESGF still needs software engineering, which is distinct from what the ESGF do. But I promised to tell you about how we work. So, but the first thing that caught my eye on Zeb's slide was something that we've been working on in the background. It's not directly related to ESGF, and nobody seemed to appreciate it before. So I'm going to say it out loud here. You pointed out that, you know, there's the choice between work on it 100% every 5, 6, 7 years, or work on it continually 10% of your time. We try this. So Copernicus put some money forward for the people who produce initialized predictions, doesn't matter what exactly now, who had this idea, had this problem of updating the prediction system, had to update the reforecast Hankaz data sets, and the suite lay dormant between these periods of time. With the Copernicus funding, it was possible to pick up this and do the management of the code and the maintenance of the code, so that through new computing infrastructure and everything else, which made the job much smoother and easier. Experience of how that worked and the pluses and minuses, I refer you to Tim Stockdale here. But that seems to be a positive thing. So it costs us one person's full-time job, but effectively that's the main part of the job. And that is now making it much easier to sort of incorporate and to bring the improvements forward. When you are put on a spot, you need to update your system now because the computer is being pulled out or something. The work with the SGF was exactly to resolve some of the problems that Zeb pointed out about it's not a piece of cake to just go there and find what you're looking for, especially if you are a user who's not in research and who doesn't have the luxury of time or indeed the expertise to do this, hasn't got the experience. What we found from running this program for 9 years is that scientists, people in a research mode and research environment put up with a lot of stuff that's not standard and make up for a lot of the errors that exist within the data and the documentation of the data. They know what to expect. They know how to, plus they know who to ask if they need to. Users, when you start to go in more broadcast mode, services mode, that's no longer something you can take for granted. And the risk that you are giving people data ready to be misinterpreted is much higher. And I think there's a responsibility that comes with that. So what we did do in the last few years is put money forward to provide some infrastructure at ESGF to maintain access to the data that our interface can plug into. So we don't take copies of the data, we just have adapters that point to the ESGF. And there now they have a more robust procedure that allows us to find the data when we want it, not in 20 days time when the person who looks after that data set comes back from holiday, or in 9 months time when they come from maternity leave or whatever it is. It allows copy to exist at various places, so you get a faster access. You have to to go through our interface to do this, but the copies exist for the users. And also we put some resources forward to try and improve documentation in a sense of making it more easy to comprehend by people who don't deal in model simulations and model development day in, day out. That's still work in progress, very much so. But that is an important thing we find because, for example, one of the things we discovered, we got involved in the testing for documentation, as Elena knows very well. We discovered that the documentation that exists in ESDoc for some of the simulations doesn't match the metadata in the files. And you're left to the answer, should I think it's the land surface model that's in the metadata, or should I think that is the one that's in ESDoc? There's no way to know that. So we try to push further into new contracts, this kind of boring, not very exciting, potentially not very well recognized in the community in a sort of career pathways, role that needs to be fulfilled in order for anybody to make any proper sense of it. And we have found, I have been very frustrated seeing that people come to us and say, well, we would like you to put our indices up there, and we would like you to put our indices through the user interface. And when we look at the models on which these bases and the model runs on which these bases are based, we discover that some of those are runs that the quality control, the additional quality control we put through ESGF, have rejected for one reason or another. So people do use this as a sort of, oh, it's there, it seems to give me what I want. I don't quite know what the limitations are, but I'm going to go with it. And then that goes and proliferates into the community. So that's the other thing that was brought up earlier, I can't remember by whom, by Shali, I think, was the idea of funding some more compute facilities to make access to the data easier. That's what I heard at this end of the table. Anyway, so we did also fund web processing services to allow people to do data volume reduction for the very least. So you can do subsetting, you can do that kind of thing. We have funded that in a spirit of deployed through the whole ESGF infrastructure. I mean, we can only fund and constrain through the funding mechanism the European nodes. But the idea was that they would promote any good practice. Any practice, we don't constrain them as to what they think is the priority, but once they persuade us that that priority is worth funding, then we say try to push it forward through to the whole of the federation, because that can only be a good thing for everybody else. But what I did learn from these contracts is that doing web processing services in a project and saying, oh, here's how beautifully this works, and this works with one thing or another, is not the same as doing it to an operational standard, which means if somebody decides I want this data, that web processing services facility needs to work with that data, needs to have been tested on that data. So I think we have the slight advantage that we do with the additional quality control we put in place for the data to make it to our catalog, the ESGF data to make it in the catalog. We already filter out data that isn't sufficiently well formatted to be able to work with the standardized software. I've mixed a lot of things there, but I hope that the things that I did say would answer some of the questions people had. I can answer them more specifically offline.
Thanks, Anka. Paul, do you want to come back on that?
I'll just put a dollar value around some things. I mean, like the reality in CMIP7 is that through the collective teams, and this was primarily IPSL actually working as part of the ESGF kind of team more broadly, came up with a better errata system than we've ever had before, actually. And the simple take home is, even though there's an underreporting on the errata system, about 20% of the archive is deprecated, retracted data. That's around about 2 petabytes of storage, which is an enormous number when you think about all this data being pushed around all over the place. If we could front load QC, et cetera, to catch like 80% of that 20%, it means that we wouldn't have copies of stuff that people shouldn't be using, writing bad kind of scientific papers on, et cetera, whatever. The more that we can kind of push that, that all the way to the front of the pipe, you actually get it to a modeling group that before you even write an ETSDF file, the software that's actually trying to push that out into a file that you're then going to go and get and put into ESGF, that would be a huge saver for everyone. Because then it means you don't have these problematic data sets that you're trying to manage across a federated system and people are copying stuff and whatever. So I think we really need to think about ways that we can work collectively as a team, and you might have solved the problem, but then you need to push that solution as far up the pipe as possible, which then means that it's not even kind of Copernicus solving it. You're providing that solution to the modeling groups to say, by the way, look, this is what we've actually figured out, and this solution is something that you can run in between generating your NetCDF files and then publishing them to ESGF. And so the more that we can do that, I've talked to Chris a fair bit about this, like there's quite a number of efforts that have started and stopped. And so what we need to do is figure out a way of actually collecting this and then, as I said, pushing this far down the pipe as possible so that modelling groups have it available to them and we stop at the source rather than having to fix a problem later on.
We have 3 or 4 years now since we did do some work with people from the SGF nodes in Europe, with STFC, with IPSL, with DECARZ, to create enhancements to the convention, the CF convention, to identify, to encode the start time, the descriptors that you need in initialized predictions. The CF convention doesn't cater for that. Everybody was in agreement. There were discussions with people saying, we don't want to put any additional burdens on the modeling community. Yes, but there is a way to do it as a sort of add-on, and those who don't do it, well, maybe they'll learn to do it. It's still not spread around, and it's still a prepare software that allows people to create the files to put them through, doesn't allow for this. I'm pushing really hard for them to make it for the CMIP7 tables and everything else, to make this part of the software that's checking at the data at arrival, or indeed giving people the template to create the data in the first place, for this stuff to be incorporated, because that helps you and helps the software we write understand exactly what's the valid time, what's the start time, how you concatenate two runs that have overlapping valid times, which is not an obvious thing to do. So that's just one example about where this kind of thing is happening. But the problem with the data being withdrawn is right. I mean, you're right that it's better errata system than ever before, but still, every time we ask people at ESGF, so the current operational contract is probably a public knowledge. It's led by IPSL's node, in collaboration with the KRZ. And we asked them, why is this data withdrawn? Do you know? Is there anything in errata to explain? Is this withdrawn? I mean, understand, for example, some data gets withdrawn simply because the support of the institution who prepared this is no longer available. Some data is withdrawn because of errors, but errata does not always provide you the place. Because I wanted to import that into our documentation to tell our users, this has been withdrawn. It's harmless to leave it in your calculations, in your whatever you have as a way done with this data, or it's harmful, in which case you must redo your calculations. And I haven't got the information in full to do this. I mean, there's a lot of stuff that is done, and we do put quite a lot of money towards this. We never imposed anything that the community doesn't want to do. And as I say, we engage with the real nodes, but there has to be some kind of, we'd like to see some kind of progress. That's what we're trying to do. I think this is the way forward. And I think from what I heard here today, these last few days, this week, forgive me because I didn't know about much of this. My impression is that the handling of data, forcings data, is not yet at the same level of maturity as the handling of model outputs from the simulations. I think there's still a big gap to be filled in how ESGF, as the host of this, handles this data and brings it to the same standards that the climate model output is handled at the moment. And that is work that needs to be done. And I think this kind of effort in trying to scope funding for it needs to take this into account. Much as imperfect that the ESGF is at handling the model output, I think that's still better, in my opinion, my impression that forcings data.
Well, I mean, I just respond to that. So the CMIP standard, which is built on CF conventions, but the CMIP standard, which is not, the actual contents of a CMIP output file is not what CF defines. CF just defines metadata basically and a whole bunch of conventions of axes, etc., whatever. But to try and make things simple, CMIP is a single variable per file, which means if you want to go get surface air temperature, you go get surface air temperature. If you want precip as well, you go get it. It makes it really easy and kind of tangible, although you're fragmenting pieces. And many modelling groups actually, the models actually write out history files which have all the variables from an atmospheric component or an ocean component or whatever else as well. And so that's not the native output. The rewriting of that through CMOR, for example, is the way that a lot of groups do it, not everyone. The forcing data sets are a wildly different beast. So, for example, with land use, Louise can speak to this better than I can, but you've got a situation where you've got multiple states that need to coexist at the same time. So you could go down the path of fragmenting that forcing data set into separate files where you've got a state in each file. But to use that data set, you'd have to have, 30 files open at once to kind of jump from one state to another. And so forcings are a different beast that, it's going to take a long time to try and figure out how you could standardize that output, because every single forcing data set is very unique and how it's used is very unique as well. So it would be great to think about, spending effort to try and standardize forcing data sets, but I think the formats are something that modeling groups are used to now, and the value add of, spending the next 3 years to try and reformulate all that doesn't, to me, make a lot of investment sense. Could be done, but the paybacks you're going to get are not going to be as big as the paybacks you get in doing the science that, gets you 2 watts per metre squared down to 0.0 something or other as well, which is science, not formats. And so I think we need to be really prudent about the way that and pragmatic actually about the way that we're actually kind of assigning priorities, what we actually go after. I think if we've got a situation where Copernicus wants better model documentation, great. Like, please figure out how that can actually be folded into the whole process, so you can engage with the 50 modelling groups that are actually producing the data sets to give you what you want, and help them to kind of realise, you know, that complete documentation, because it's going to benefit absolutely everyone, actually.
I don't think the complexity of the data precludes the need for proper documentation as to the versioning and everything else. So, I mean, I'm not saying that the strictures imposed on model output need to be imposed in the same way, but I think data governance, proper data governance, could have something to add to this.
So I think in the previous round of input for MIPS, it was very different. In this round, I mean, I basically agree with you, Anke. It is, for want of a better word, insane that we don't have this already. And so I just went and wrote something that I call input for MIPS validation. Every file we get, we run through it. So now you don't have the metadata errors anymore. The issue I spoke about before, we couldn't download the file. We picked that up, but we had pushed our data provider so hard that we just said we can't force them to go and do this again. They're going to crack it and they're just not going to provide any data. And so I think that's part of this, right? It's like that user support thing is tricky. And my feeling is really it would have been faster for me to rewrite the files than to try and explain to them how to rewrite them. But on the flip side, and Paul makes a good point, if they're giving us something and then we publish something else that's not the file they gave us, that then looks super weird. Because if they give it to someone else and there's two different files floating around, and like, what do you do about this? So I think this is where there's a really tricky question about how you do this kind of interfacing stuff that, like, we're trying to do our best, and Louise was an absolute hero in this. I think I put Louise through 15 iterations and then we got there. Thomas and I sat down for 3 hours on Zoom and kind of went through, how do you install this stuff? Why is the file failing? How do we get the formatting right? And then he got there. But it's, you know, it's a non-trivial lift. But I think for this round, I think the input from MIPS data will be better than the CMIP data. Cleanliness, easy to understand, units not being wrong, all this sort of stuff. But having said that, also in the benchmarking team, we're going to try and do the same thing as I understand, which is that when the data is submitted, it's run through a validator before it can go anywhere. And so at the moment, we're only doing metadata validation, but I think the next step is actual data validation. So, you know, are we out by a factor of 1,000 because we're in, you know, kilograms, not grams or whatever, this sort of stuff, which is not that hard to do once you kind of know, and you guys are absolute experts at this. You've done this more than anyone in the world, I think, seeing some of the stuff that's on Chris's screen yesterday that he was showing people. And so I think that, like, this is actually not as anywhere bigger lift as I think Paul's saying. I don't think it's 3 years. You know, I did it at half time for 3 months and we got pretty close. And so I think the effort's worth it. You know, if you think about how much time people spend analyzing this data, you can come up with figures like 30 million, 300 million euros a year, people faffing around with this, putting up with the kind of stuff that people in professional or people in private institutions would never put up with. Just PhDs, you say, go and say, I don't care if it takes you 4 months, go and figure out how to load this data. And they will just spend 4 months. If you can make that 4 hours or 4 minutes, and you do that over every institution in the world, you could save the world, I don't know, 3 million, 30 million, 100 million euros a year. Like, I think this is actually worth it. And I don't think the lift is as necessarily as hard as we need, but you do need both sides to come, because if you push people too hard, they just walk away. I think that's the only kind of other side of this puzzle we need to work out how we do.
I would just add that I think this is a challenge that needs to be recorded with quite high prominence. The fact that the connection between the coordinators and the modeling centers, the data providers, remains a challenge, because we could, much as we might want to, we can never reach out to the modeling centers and fund them to do things the way we'd like them to do. That's why we need to deal with the middle. And it's one thing to ask them when they produce them, it's another to ask them 5 years on when this is still the state of the art. So that's not, I think that's needs to go as a potentially an irreducible issues, and see how we work around it, because you are not going to be able to, nobody's going to be able to fund everybody to do things exactly the same way.
Okay, we're running over now, so I think, Paul, have you got a very short comment? Not sure. Okay, right. Because we've got sessions later where these topics are going to come up again and for further discussion. I think it was really helpful. So we almost did highlight some areas of like raising the visibility of the importance of the data and of the challenges of getting the data out, recognizing the people involved and that dependency tracking from observations and all the chains that are required to get this data out. That kind of community effort, both in terms of engaging with the modelling centres, with the data providers, but also in perhaps a community effort in capacity building at some level for sort of software skills for scientists, but recognising they can't be doing that full time because that's not their passion, I think is maybe Zeb put it. And maybe thinking of how we can look at the user requirements and see how we can match that with the demands for funding elements of these and structurally where everything needs to sit as well. So in the sessions later today and also into tomorrow, we'll have a chance to go back to some of these questions and sort of delve in a bit deeper and look at solutions and tangible actions. So next session up is focused on users. So we'll reconvene at 11 o'clock sharp, please. So see you all online at 11 o'clock and in person people have a good coffee. Thank you, everyone.